Hi, my name is Sebastian Gamboa, and this is my term project for 15112 in the spring of 2017. For my term project, I made a gradient and electric field solver. So let's jump in. First, we'll go to the solver. And if I don't know what to do, I'll open up the instructions. As it says, I can input an xy polynomial, solve for its two partials, and get the gradient field of the two partials. Let's say I want to solve for x squared y squared minus 3x squared. I press solve, and here I have the partials. Now I'll press the gradient field button. Here we see the vector field representation of the gradient of my inputted function. The magnitude of the vectors are represented by the hue they have. The darker the blue, the bigger the magnitude. I can also click on the x component and y component to directly make any polynomial vector field. Let's say for x, I want x squared minus y squared. And for y, I want negative x. We see that our smallest magnitudes lie on the line y equals x and y equals negative x, as we can see by the very low hue on these lines, in accordance with our x component of x squared y squared. Now let's go to the electric field. I click on the instructions to see what I can do. Let's see. So I can place some charges, I can change the magnitude of the charges, and I can import from my gradient field. So let's place some charges. Place one here, and another one here. And I'll hit refresh field. And we get our basic electric field. Now let's add some bigger charges and a negative charge. So let's say I want to charge maybe 40. I'll place that charge down here. And I want a bigger negative charge, let's say 68. And I'll place that charge up here. Now I'll refresh the field. And once again, we get the electric field of this charge distribution. If we click on a vector and press H, see that a little particle appears that starts moving. This we get the particle, or the path of the particle of a point charge that would move, how it would move in this electric field. We can undo charges if we want to, and then we can redo. So we can edit this to our heart's content. We can also import our gradient field to see how our particle will act in this gradient field as opposed to our electric field. So we release our little particle. We see that it goes right a little bit, then turns around, and it leaves the gradient field after doing a little loop. If we hit refresh field, we still see that our charge distribution is still safe. That's all. I hope you enjoyed, and thanks for watching.